So let's go through some of the Java questions asked for the interview. Uh, First one is, which data structure is used when there are millions of data to add and add? So we want to, there is a scenario that millions of customer records needs to be written, not to retrieve, just to write. So for that purpose, what kind of a data structure is better? So let's see. I think ArrayList performs better if you are not going for concurrent operation or multi-threaded operation. ArrayList will perform better than linked list. So let's see. Let's find out. Okay, let's test the performance of a linked list and an array list for adding 10 million record. So we'll first create a list, array list. First create an array list of string. The array list we can specify in capacity. It's 10 million or 1 crore values. We'll add okay, let's capture the time. Capture the start time and end time and see how much time it's taking. So let's run this program. Okay, it's taking 1201 milliseconds. 987. Okay, so let's test it with the linked list. Linked list we cannot specify initial capacity, so you can see that it's taking more than double the time than array list. So to simply add data also, linked list is taking more time. We need to test other things like concurrent linked queue using multi-threaded application to see whether that is more performance or not. Anyway, that I will test in another video if required. So how a hash map work in Java? I think this one everybody now knows, because this is a common interview question which was asked for a long time. So I am not explaining this. And another is hash map thread safe or not. As you know, hash map is not thread safe. So how to make a hash map thread safe? Hash map can be, we can make a hash map thread safe using collections dot synchronize map. Also there are other ways, other thread safe implementation of hash map, that is hash table and concurrent hash map. So hash table is in Java since old Java itself. Hash table exists in Java. In hash table, the issue is that all the methods are synchronized. So uh, the performance of the hash table is much slower. That is why in the new Java version, concurrent hash map, Java come up with concurrent hash map. So the concurrent hash map don't lock while reading the data. That is the get operation. There is no lock. So the thing is that it use a segmented log. Concurrent hash map works by dividing data into small segments, and it allows each thread to lock one segment at a time, so that multiple threads can work on the data concurrently. So if you want faster operation in multi-threaded environment, now it is better to use concurrent hash map. So another question is how to print items of array list in reverse order without using for loop. This also multiple ways of doing. One is using the list iterator. I think you all know the list iterator in Java. So it has a method called dot iterator dot has previous. So while iterator dot has previous, we can print the previous value. System dot out dot print previous. In that way we can do. Another is first we can use collections dot reverse of this list, then we can use a iterator and iterate through the list array list. That way also it will work. So another question is whether hash map allows null or not. Hash map allow one null key and multiple null values. And what about tree map? The thing is that tree map allow null. Tree map allow null key in the first place or in the last, but it usually throws null pointer exception as well. So that is due to the comparator which is used to compare, because tree map everybody knows that it uses a red and black tree and it is already sorted, so for sorting it using comparator. So let's see how the tree map, whether it allows null or not. Let's see. So let's create a class to test tree map. So we'll create a tree map, then let's see whether it allows null or not. So here 2b 3 4 d see. So what will be the size, whether it will print or not. Let's see whether it will try to print the tree map. It won't print because it will throw a null pointer exception. Let's see. Yeah, it is cannot invoke java.long.comparable.compare to this using the comparable interface to compare. So first element is null, so it is getting the null pointer exception. But how to make this work? So for that we need to use a comparator dot nulls first comparator dot natural order. So let's see, after making it nulls first comparator, let's run. So the first element is null. Okay, so let's change to nulls last and see whether the null going to the last. Now you can see that 2 3 4 and null. So compare this tree map allows, as you can see, the tree map allows null key, multiple null values as well. Okay, let's see whether it allows multiple null values. So only due to this comparator it is having the problem. So how you now know how to fix that issue as well. So that's about tree map. So the next one is, what are solid principles in Java? Solid principle, I think you everybody know this, but still I will tell the what are the things. That is a single responsibility principle, that is the S. Then the O is open closed principle. That means a class is open for extension but closed for modification. And next is Liskov substitution principle. So everybody know that what is a Liskov substitution principle. These are all we need to I need to make a separate video, otherwise I will tell in one line. Like if there is a class A, if class A is a subtype of a class B, then we should be able to replace B with A without interrupting the behavior of the program. That is the Liskov substitution principle. Then interface segregation principle. So interface segregation means we don't put a lot of things inside one interface itself. For example, if we want to means if we want to process some Excel file, if there is a interface called process file, and there are multiple methods like process Excel file, process CSV file, process test file. So in this case, if somebody wants only to process Excel file, they simply waste of, they don't want to implement the other two methods. They only want one method in that. So in that case we should again create interface with a single method. That is, we have to create, we don't put lot of methods inside one interface. One interface should have one method, and another is last one is dependency inversion principle. So dependency inversion principle means everybody has a know it is dependency injection which we are using in the Spring framework. For example, if we have a customer class and we have a customer service, then it's we can inject that customer service to customer class through constructor injection. That's for an example. So we don't need to tightly couple. So to loose coupling, we prefer dependency inversion principle. So that's about solid principle. And another is what are the new features in Java 8 that you need to go through properly all the Java 8 features. So you can see like there are functional interfaces, lambda expression, then streams for each, optional, default and static methods in interfaces, Java stream, and Java datetime. All these are uh, some of the new features in the Java 8. And next is what is the use of finally. So in this case, there is no what is the output of this program. This will print first, third, and fourth. So if the fourth is printing, what is the purpose of this finally block? If there is an exception also, the fourth this value will print. But why? What is the purpose of finally? Finally is required because if there is a return statement or continue or break or something, uh, some statement uh, which is in the try block, so the control won't comes to the last. But anyway, if we write a finally block, the control will goes to finally block and finally will be executed. So for resource management, we should definitely use finally block. Okay, these are some of the simple Java questions. So we'll come up with more questions.